Alrighty, let's just get down to it. This is the section where I take questions that people have asked in either the comments in the bottom of videos or through correspondence or something like that, that I think would either be useful as, informational to the broader community, or that I want to spark further discussion or something like that, and I answer them all in a video because I don't expect everybody to have read through all the comments. That's ridiculous. I also usually take this as an opportunity to make announcements and news and things like that. So anyway, the next live stream is going to be kicking off the Ender series, and that was supposed to have happened before, but I had some kind of problems with YouTube. Apparently, in the last video I talked about the nonsense, so I'm going to try to avoid that this time. I was planning on doing that this weekend, but just like last week, I started on a massive dose of antibiotics for a head thing, and I'm all kinds of messed up from it. So I'm not going to be doing the live stream this Saturday coming up. I'll be finishing those up on Saturday, and so I'll just do it the next weekend. So put that in your calendar. I'm not going to put a reminder thing up until a couple days before, scheduled event, because I don't want the key to expire and go through all the crap that happened last time. But I will re-announce again, in whatever videos come between now and then. So to kind of make that up to the 3D printer folks that watch, because I've had to push that back a couple times, I'm going to start in on the new integrated 32-bit board reviews a little early. The reason I've been hanging on to those, the reason is twofold. One, because I wanted a common reference platform to do all those on, so I was just going to do all of them on the Ender once we get that up and running. And the second reason that I haven't been doing those reviews is because, I'm a big open source proponent and things like that, and I find it encouraging that a lot of the companies are recognizing that the 3D printing community, the RepRap community, values free exchange of information and that type of thing in open source, and they've been trying to move in that direction, but they've needed a few nudges along the way because it's kind of a totally new concept for some of these manufacturers. So I keep a spreadsheet, which I will put up there, at least part of it, where I track the certain aspects of these boards and different companies to see who's in compliance and what's available and things like that. And it's been kind of a countdown to when the files are released, then I can start in on these videos. So after that video I put out that was kind of hey, if you say you're open source, open the source already, a few of these companies have actually rolled the source out. So I watched their GitHubs, things like that, and I've been waiting and got frustrated, put that video out. But now we have them, so now I can continue. So thank you, companies. I will roll out your names as I do the board reviews, but you know who you are, and you know the reviews are going to be coming. So we can't all just be negative Nancy's and yell at people when they're not doing things right, but we should congratulate them when they are, and encourage that kind of behavior. So thank you very much for releasing those files. It makes my job, I would say it makes my job easier, but it makes my job possible at all. Because I'm not going to put out a review that's just hey, here's a board and I plug things into it. So we got to get into the nuts and bolts. Now we can do that without spending a week reverse engineering. Let's get on to the questions. So, as with all of these videos, I put a time index in the video description, so you can go through and skip around to whatever it is that interests you, skip past the stuff that you think is dumb, etc., etc. But right now I have to pause my camera and dump the memory because I'm about to run out. Then I'll come back and do the questions. And here we are in the future. Sorry about that. I took a little break too to rest my voice. So anyhow, let's get to the questions. Alright, for some reason I'm only able to scroll back 2 weeks. Lame. David Mulligan says, Alex, it would be nice to have links to the cheapo test gear you'll be demonstrating ahead of time so we can follow along with you. I've got a Sele clone for $10, but what scope are you looking at? Yeah, maybe I should announce that. I'll have to wait until the other stuff comes in. The multifunction tester was one of those T4 LCR. Where is it? Oh, it's behind the curtain. And that didn't have granular enough choices for the test, so I'm getting one with the encoder on it, supposedly an upgraded model. I'm also going to try modding the encoder Because, wait, that's further down here. Yeah, Sienna Gears said, I saw a Russian-speaking guy mod the LCRT4 to accept an encoder. It's not even all that messy, and then a link to the video. So, yeah, I'm going to try that mod, too, and see how that works. Because that one's a little bit cheaper than the one I'm getting. So I'm just going to, like, plunk the encoder on there and then, like, kind of A-B and see what's going on. And then as far as the oscilloscope, I don't know. I have this one already, which is the DSO 138, very limited bandwidth. I'm going to see if I can find a decent source for a higher bandwidth model, preferably dual channel, because that's a single channel, which is fine for some things, but if you want to measure like differentials, then you need a second channel because you need to compare one to the other. So I'm going to see if I can find one that's slightly quicker with dual channels, and then compare that and to the single channel, and then maybe I'll go out there and carry my 40-pound oscilloscope back here and compare it to a real one, even though it's ancient. Paul McGowan says, you're lucky enough to have gotten those 2209s. Apparently there's a shortage if social media is to be believed. Yeah, I heard there's a shortage of the 2209s. I don't know if that's a production thing or if they just misunderestimated how many they were going to need. But the boards that have the onboard 2209s, I have gotten those from a couple different manufacturers. And I've gotten 2209 in the step stick format from a couple different manufacturers. But I ordered them so long ago, and I think they may have made revisions since then. I'll have to check the version numbers on the boards. But those are going to be in tests coming up, too. Thorsten Eggert says, any chance you try Klipper instead of Marlin on your STM32 stuff? I have not tried Klipper on 32-bit boards yet. But that was kind of the draw for me initially, was like breathe new life and new processing power into, 8-bit stuff by, sort of distributing the computation amongst a couple different processors, but a lot of the new 32-bit stuff is so cheap that it just kind of makes sense to run it on there as well. So yeah, I will be doing some Klipper stuff in the somewhat near-ish future, I think, as well as like things that I also haven't covered in the past, like Octoprint on like various little Raspberry Pis and clones and things like that. That'll all be rolled into the Ender series probably, as sort of like a a tertiary, like, hey, an alternative firmware, or hey, get it set up with Octoprint, that type of thing. That's probably been covered to death, but I don't think anyone's covered rolling the actually like Armbian distribution and building Octoprint from scratch on like a non-Raspberry board. Maybe they have, I don't know, but maybe I'll do that. Christian Peterson says, looking forward to some great info. I have parked my Ender in a dark corner for the time being, waiting for some abuse. I've been busy with the Tronxy X5S, yada, yada, yada. I'm going to convert to linear rails. Perhaps I could do it through an affiliate link from your channel. EU warehouse would be the bomb. Yeah, I've kind of gotten some of the EU affiliate links stuff down. That's another thing that held up the Ender series too, because I wanted it to be a kind of like mod and, or like evaluate, modify, reevaluate, like build along, recommend, cheap alternatives and cheap upgrades and things like that. But I tried to sign up with affiliate programs for like various different places that people are into before I started that series. And I managed to do, I think I mentioned this in a previous video, like US, Canada, Germany, and UK for Amazon. And then I couldn't get, Germany then dropped me, and then I re-signed up again because they have different standards than everybody else, and something with the redirect to my blog, they didn't like that at all. But I tried to sign up with Banggood, and they also had problem with the redirect. I didn't think it'd be that big a deal. All it is, I took a like a vanity URL, it's just alexkennis.com, and send that as a redirect to the blog, or I send that out on like Twitter or whatever social media, so that you can then just go there, and then whatever I have parked there at the time, like it'll take you to wherever you need to, like this YouTube channel or whatever. Sienna Gears says, here's a radical thought. What if instead of building the video series structure from the ground up, you can assume we know things that have been explained by other people like Thomas and Shep and like all those guys. There's not like there's a lack of 3D printing tech education on YouTube. Yeah, I agree. I read this comment and like kind of tried to reevaluate some of the things and see where my place and all that was, because I don't intend for this to be a like just 3D printing. I like to tackle things in a way that you learn to tackle things yourself, and that's knowledge that's applicable to anything you need to do. But there are some things that I want to cover, like the bootloaders and like fundamental differences in microprocessing platforms and basic testing and experimentation as it applies to like a kinematics platform and that sort of thing. So I'll try to wheedle out like the real basic stuff. I just want to make sure that like I get something out of the way and then have a reference for it if I get to that subject within the course of like a review or something like that. Because there's some videos I've watched, like people will do a review of a board and then stop halfway through like a 10-minute video and spend 7 minutes explaining how to install like Marlin on it or something like that, and then jump back into it. And I'm like, well, I mean, this was essentially a how to install Marlin on this board video with a couple other things thrown in. So I don't like when that's how videos end up being, so I don't want my videos to be like that. Samuel Lionel, this is about the failing Omron switch video. You, sir, are a life-saving madman, worth every minute of this hour and 15 minutes diatribe. Well, I thought it was longer than that. I always wondered why my Logitech G5 lasted 10 years and my G903 lasted just 1. If you got a whole year out of your G903, you're in the minority. Before one of the switches failed despite costing 3 times the price. Yeah. I thought that video was going to be like just me putting down a bunch of like rambly tech stuff and like 12 people in the world caring and, you know, getting something out of it. But it's actually sparked a lot of discussion and a lot of communication with me from various people. So that's good, I guess. I'm no expert in that, and I'm not like a big FPS gamer or anything. I unfortunately don't have the time for that type of thing. On the upside, there are smaller brands of gaming peripheral manufacturers out there that are taking this very seriously and trying to address it. So that is to be commended. Yves Savigno says, thank you for sharing. I'm more a mechanical guy, but was curious and looked at the SKR boards on GitHub. It seems both the SKR Pro and the SKR 1.3 schematics have been released. Yes, they have been released, and if I forgot to flash that chart up here, I'll flash it up now. So I'm going to try to hit as many of these boards as I can. A lot of them share very similar characteristics. I've been poring over the schematics and making notes like since the day that they posted them. John Brewfer says, bleeping hell, what a bleeping horrible noise to start the video with. Are you related to Bill Bruford? He's one of my favorite drummers. Adverse Effects says, oh man, I just ordered 2 of the bigtreetech SKR 1.3 2 days ago. Please tell me they don't have a fault. He was referring to the open source rant video. I kind of based my example of why we need the electrical diagrams on a USB problem that some boards were having. It wasn't the SKR. It was a general reference to STM32 boards, because of the way that the bootloader works and the pull-ups enable their pull-downs and then the pull-ups to enable different modes of USB. It has to be implemented in a particular way, and it has to be timed in a particular way, and that varies from chip family to chip family. So if you have that information in your head and you can see the diagram to see how it is they were trying to enable it, somebody who knows the whole big picture could just say, hey, you know, increase the delay on X, or make sure pull up Y isn't disabled by, you know, a GPIO pin until, you know, something happens, that type of thing. That's one of the reasons that I want to do like a bootloader video and that type of thing, because we can get that legwork out of the way, and then I don't have to reiterate that through every time I do a board with a particular microprocessor family that has particular peculiarities. I can just say, refer to my bootloader video, and that'll explain why it does it this way. And I can cover like HID bootloaders and mass storage bootloaders and DFU bootloaders and OTA bootloaders and all that stuff. Anil Kumar says, what about the bigtreetech TMC 2209 driver? There's a video on YouTube that describes a design flaw. Could you please elaborate and confirm the issue? The fellow who made that video replied underneath, Kazalar, and you can check out his video if you want. Yeah, I went and watched it and saw what he was talking about. I'm not sure which version of the board that I have, but I'll check it out. If I don't have the video with the weird flaw on it, I'll just like kind of summarize what the video says and then send you over to Kazalar's link to watch the whole thing if you want. Felix Hauser says, I got an SKR 1.1 that doesn't communicate with my computer, although it does communicate with Octopi. I was wondering if it has something to do with your example here. Yeah, I'm going to have to cover that too. I mentioned underneath that depending on what OS you're running, you may or may not need a driver for the virtual COM port or the DFU bootloader, whichever it is that you're doing. But if you have like an older system, there may be some driver juggling, and I may have to walk through how to install drivers with Zadig or whatever it's called, or just show you where to get clean drivers rather than like installing root level permissions to random drivers that you download or you get off of SD cards from God knows where. But yeah, I can say with those particular boards, like plugged it into Octoprint. I assume he's running Octoprint on a Linux or Raspberry Pi or something like that. Those drivers should work fine. Like I plugged them into a Debian-based build and they just worked. Plugged it into a Mac and it just worked. Plugged it into Windows 7, nothing. Plugged it into Windows 10, didn't work at first, but it sorted itself out. So it really depends. Peter Ellen says about the open source rant video, we're still fighting the CE standards battle and have been for decades. Everything comes with a CE sticker, but virtually nothing actually has a certification. Yeah, that's a problem. EU is much more stringent in the consumer space about like those types of certifications than we are here in the US, but we also have pretty strict standards here in the US as well, but usually that's for like tolerance critical or like, you know, life critical applications as opposed to like just consumer stuff. But there are like basic safety standards that you usually have to pass. Other than that, it's like it's kind of Wild West for, you know, like little gizmos and thingy-doos here in the US. But yeah, I totally hear you. Like fake UL and CE stickers and that type of thing, that can be a serious issue. Marcin Jakubowski says, nice rant, here's mine. Then he post a link to his Wikipedia. I think that got caught in the spam filter because of the link, but I pulled it out and I stuck it back under the comments. So you could click on that if you want, where he just goes through his, you know, like, it was like 10 or 12 steps or something like that of, you know, compliance and whatnot with the open source things. A while back, I recorded a big, long video about, like, open source and GPL and MIT license and open hardware and like all that stuff, but I didn't put it out because it was really long and really dry, and I figured people who were going to watch the video already knew everything that I was going to say and maybe even had more experience with in some of those areas that I did. But yeah, it gets confusing with the different types of open source licensing, what you can and can't use. A lot of people are using, you know, like CC stuff these days, but there wasn't really a hardware thing until relatively recently that you could really use. I mean, you could like just say, hey, this is CERN or MIT or whatever and just roll with it. But like even the early sirens, but even the early like RepRap stuff that is kind of filtered down through the generations to the printers that we have now, they release the hardware information or the hardware intellectual property under like a software license, the GPL. GPL is a pretty restrictive license as well, and it's not completely applicable to hardware, so it's kind of a goofy space. I think like moving to separate open source hardware and software licenses is probably the better way to go. One thing you can get from that link and other places is that there are different types of open sources, and they're all fine to one degree or another. You just have to kind of like say what kind of license you're releasing it under and then honor the license. So Pedro says this is under the failing Omron switch thing as well. I'm a Brazilian. The video is a bit complex for my understanding. The mouse gives double click problem. Which is the best switch to replace? What could I do since there are no double click mice on the market? If you want a quick fix that's easy, the Japanese D2F Omron switches are microcurrent rated, but really any micro switch that's the same form factor as the ones you usually see in there that either says microload or microcurrent rated, or it says logic level rated, those will be okay. Now, any of those, they're rated at those low currents because they either have a gold plating or like some kind of gold deposition on the contacts. But if it's not meant for, repeated use, you can wear that away pretty quickly, and then you're back in the same boat again. Well, maybe not exactly back in the same boat, but the point is they're not as mechanically rugged or electrically under certain conditions as the switches that you're taking out that were failing. But I've been testing out a couple of different switches and seeing in mice that have known to fail with like the 50 million Omron switches, using those microload switches that instead of being rated at like 50 million cycles, they're only rated at like 100,000 electrical cycles or things like that. And I can tell you they've already well exceeded 100,000 clicks on those. I've gotten like 2.5 Diablo seasons into some of the Japanese Omrons and Honeywell switch, and I haven't had any problems at all with them yet. I'll let you know if problems develop. Okay, here's a question that I promised the asker that I was going to address in a Q&A, so here it is. This was about the ramps and duo mod, not particularly using a duo, but using a different board, which is called the Grand Central M4 from Adafruit Industries. If you want to check that out from Adafruit, go ahead and do it. What they did was they took a Cortex M4 microprocessor, plunked it onto a Arduino Mega form factor board. I do plan on getting those eventually and seeing what I can get running on them, but at the moment I'm resisting the temptation to buy one because I have so many other things to do. This was a question that led me to make that STM32 plus the full graphics display video just to show how to make a real stripped down test bed, and the point of that was really just to show how to hook the panel up to the microprocessor and what pins actually stand for what designations, because you need to kind of communicate like, what's MOSI, what's cable select. I just see like, E on the back of the stupid thing, RW, what the heck does that mean? So yeah, that was for the purpose of, if you have to strip everything down, like he was using klipper by the way, if you have to strip everything down to just the firmware and see how the board behaves, or hook up the board on a subassembly or something like that, that's how you would hook it up and test to make sure the graphics themselves are working without worrying about the panel, which is all the controls that go on it. And it'll let you isolate the wires that are sending those SPI signals. So if you wanted to hook a logic probe up to it, you could see if you're actually getting the proper signals. And that's, again, why I wanted to do that logic probe video last week, but I got squashed for time and couldn't do it. Mostly because the website that had all the driver install packages was down, and they didn't have a mirror. They took the entire thing off of GitHub and hosted it on their own like personal servers, and they do like hourly build generations or things like that. That's fine, but it doesn't do you any good at all if like your whole website is down for like 2 days straight. So I actually like messaged them through Twitter, and I was like, I don't know if you know or not, but your entire website's down and nobody on planet Earth can download any of the drivers for these. And then it was up the next day, so hopefully it's still up. I should go download those while I can, just in case. But I did in that video answer some of the questions about that panel and like 3.3 volt and 5 volt compatibility, because those, all except for some of the really old ones that are marked 5 volts, and even those 5 volt ones, they all seem to work fine with 3.3 volts. And I found that out when I was doing that the rearm stuff and the DUA stuff, because those panels, like, they just worked, and I didn't think they would at the wrong logic voltage. You just have to supply 5 volts to the backlight, because, the LED drop is going to be more than the 3.3 volts will let you, so you just can't see anything on the display. It'll still accept information, but you can't see it. So they do, and this doesn't help with like the rip-crap discount full graphics panels, but they do have a voltage doubler output on them, so maybe I'll look into, if we're not going to get a next generation rip-rap discounts with that panel, maybe I'll look into doing like a mod series on that, or like a mod video on that panel showing you how to hook up the voltage doubler, so you don't have to worry about 5 volt on boards that don't have it. They should all have it though. I mean, worst case scenario, you have to run it from like the secondary power pin or something like that, or 5 volt USB if you're running it there. But Yeah, maybe I'll do that just in case we're moving into a world of, 3.3 volt only boards. Another thing to add to the list. Yeah, you shouldn't have to do any level shifting to those panels unless you got one of the old ones that can get a little bit cranky. They're getting rarer and rarer these days. Like, that used to be a thing that popped up from time to time, like online. People would complain about it, but it seems like they're kind of flushing through that stock, and like all the new panels seem to be happy with 3.3 volts. And again, like I said in that video, they'll operate down to like 2.7 ish for a threshold. So it's they should be cool. But if you want to check and see if you have one of the cranky old panels, level shifter boards are super cheap. But all that's to say is, like, if you're in uncharted waters in too many places at the same time, like you're using an alpha of a firmware on a brand new board that's in alpha stage with a lot of the support, first generation, from Adafruit, very green libraries, and you're trying to get like unsupported peripherals to work, divide and conquer. So separate the firmware from the libraries, from the drivers, from the hardware in different places, and try to isolate as much of the hardware as you can and get one thing working at a time. When Marlin was just getting like STM support together, and I was doing a bunch of testing for some other people and working with the like STM32 Duino guys on like bootloaders and stuff, there was virtually nothing that worked with those boards. So I didn't jump into like, hey, let's do like a rep wrap discount LCD panel. I was like, hey, let me just grab this character LCD panel, try to get that to run in serial mode, and then if I can get stuff on display, awesome. Then try to get the encoder working. Like, okay, awesome, encoder works. Now we'll try to get the SD card working. Awesome, finally got the SD card working. Now we can plug the panel in and worry about that. Under the blue pill with the full graphics LCD, Roberto Acera says, awesome video. Is there any chance to combine this hack with ramps? I mean, free up a ramps mega combo of writing all the stuff to the LCD, combining ramps and mega with the blue pill and LCD, creating graphics. Would it be very difficult? I had replied to that. You can do that in Klipper, I'm pretty sure, because it's set up out of the box for intercommunication of microcontrollers. Technically, there are different buses that are meant specifically for a mesh of microcontrollers, like CAN bus, which is what it was created for. It's used a lot in the auto industry. As CNCs, a lot of those use CAN bus, and robotics and things like that. That's not something that we've gotten into with the 3D printing, really, because it just hasn't been necessary. Maybe up until now, who knows? We'll see if somebody does brilliant with like little satellite MCUs, especially since these MCUs are so darn cheap. But you can also do it with any full duplex protocol. Marlon Scott jumped in underneath and said they did an experimental I2C, which is 2-wire serial protocol, and bake that into Marlin. I haven't really played with it. I want to, because every time I compile my firmware, I see it there, and I'm like, I want to get these little gizmos talking to each other. But the problem with that is it's 2-wire and serial, and trying to emulate two-way talking back and forth when you actually can only really go one way at a time. So if you have one board that's talking to another board, and this one's doing the main thread and this one's doing something else, you can send anything you want to that and it'll display it. So if you want to make a display who is drawn by a separate microprocessor, you could do that. You just have to turn that into a bridge. You don't really have to, since they have bridges built into a lot of these LCDs anyway. But if you wanted to do something cute with it and put up other graphics, you could do that. You just have to have it respond to the generic G code that's going to be coming across the serial. But if you then want that panel to talk back to the main controller and not have it like block the main thread and get all jittery, you have to kind of throw a signal at it that this one can then say, okay, now I'm ready, and then it'll say I'm ready to receive it back, and then throw a signal at it and say, are you ready? Yeah, I'm ready now, and then throw a signal back. Also, if you wanted to do all the drawings of the on the LCD screen yourself, you could do that as well, based on what the menus that they have in Marlin, if you want to keep it, or just roll your own firmware. It would take a lot of work, though. And I did say, like, that's how a lot of the graphics panels work. like the touch displays and things like that. They have their own firmware running all their own stuff, and then they just talk back and forth over serial. Rishabh Gupta asked, and this I found interesting, can we replace the 128 by 64 LCD of the RepRap discount with a 128 by 64 OLED? Or would it just be will it just be replacing or something else that needs to be done? White OLEDs look much cooler. Now, the reason that I thought this was interesting is because I have a couple RepRap discount panels with the LCDs pulled off because I've, yanked them off to use for other things. So there's really nothing stopping you from reusing that PCB that has all the other giblets on it. So like the EXT connectors and the SD card and the encoder and the beeper and the reset button, like all that stuff is just broken out on pins. And all of the DB headers, the DB, I don't forget what they are, like 2 through 9 or whatever, that are in the middle of the back of those LCDs. If I had one in my hand, it would be easier to explain. But those aren't soldered to anything. I think one might be grounded, but you can basically stick whatever you want in there and then free wire to the back of the board if the pins don't line up with what happens to be broken out from those panels. So I have some of those OLEDs. I don't have a big 128 by 64 OLED. I have like the 1-inch ones and the like 1-inch by 1/2 inch, really teeny tiny ones. Both, well, I have 3 of them. I had 4, but I blew one up. Those all that I have run off of I2C. So you could, if you have enough pins, or you could adopt pins from features you don't want, like maybe the beeper or the kill switch or something like that. You could just wire that through to I2C, send it to I2C, and then communicate through Marlin that way, or whatever your firmware is. I'm not sure because I didn't look which OLED panels are supported already in like Marlin. It's gonna depend on the HAL layer for your particular board too, to see if there's a library for it. I imagine those would run off of the U8G lib, in which case there's Marlin does their own U8G lib library, so you might have to roll a driver for it. I'm not positive. I'd have to take a look. But yeah, there's nothing stopping you from reusing that panel and just sticking a different kind of display for it. You just have to figure out the firmware situation and the wiring. So I may do that. I actually, right after I read that comment, jumped on AliExpress and started looking at some of those boards, and the screens are oriented weird and things like that. They weren't exactly the right size, but I do have that on my to-do list for the future. So if I do stumble across a board or that looks like it, or a LCD that looks like it'll fit on that panel nicely, I might do that. Under a very old video, the high-speed real-time experiment with the E3D Volcano and a TMC 2130s at quarter stepping. That was one of the first 3D, maybe the first 3D printing video that I posted. Lucas DeCampo asked, what about print quality? Do you recommend it as an upgrade from the stock hot end on an Ender 3? Quality is what I'm looking for, and to reach temperature for nylon. Maybe E3D V6 instead of Volcano would be a better option. What do you think? I intend on covering hot end things, obviously, when we get into the Ender series. So, we and I all kind of just use Volcano as the colloquial term for high output hot end, because E3D kind of kicked off that trend. There are others on the market, and you can cobble one together yourself. I don't know if I'll specifically be covering the Volcano, but I'll definitely be covering high output hot ends, and I may try like putting a Volcano block and nozzle onto the Ender heat break, and there's a heat sink, and there's a couple different designs of those. ModMike sent me one, and McEwen 3D sent me a couple, and they're different generations where some thread in and some press in. There's a set screw, and I have to figure out a way to test like the thermal performance of those, the thermal sinking performance of those heat sinks, because those tiny little cooling blocks, especially with the little fans that they have on them, do tend to have some heat creep. So I want to do, if I put like a Volcano block on there and like a full metal hot end, check the heat creep on like a long print and see if that's an issue or not. So yeah, I do intend on covering a bunch of that stuff when we get into the hot end section of that video. There will for sure be some Talk Nerdy to Me videos leading up to that, because if you recall, I tried to get into like the hot end and extruder, like mathematics and the thermodynamics and the radiology and all that stuff, and it ended up being like 2 hours worth of video when I stopped talking, not 2 hours complete. So I'm going to have to try to boil that down and break it up into bite-sized segments that'll kind of segue into that test, so we'll have a common ground for talking. But yes, and I answered Lucas underneath, and I said, you can just throw a volcano on whatever you want and see how it does. I unfortunately don't have the answer for like every specific printer, but I do have volcanoes on, I think, every printer here. No, there are two. There are two that don't have volcanoes. Just because I like having that additional throughput available. Because if you put, you know, a high output hot end on there, you don't ever have to worry about your, well, not ever, but with under reasonable conditions, you don't have to worry about what your maximum throughput is. You can just adjust based on the kinematics of the printer and not where you're going to start restricting flow and under extruding and things like that. But if you are going to be using a larger nozzle printing very quickly, like I did in that video, you need a lot of cooling. Like, technically, you need more cooling than I had in that video, and that was like two 50 by 20 millimeter blowers, I think, and it was still having a hard time keeping up. So yeah, the stock hot end on an ender, I think, it's a 40 by 10 millimeter blower, like a tiny thing. So yeah, it's definitely just one of those is not going to be enough to keep with higher speed printing on a volcano. Now, if you're doing a volcano at like 20 millimeters a second and using like a 0.8 nozzle or something, you might be able to get away with it, but you'll probably need more cooling, and we will test that when we get into the series. On the Z-axis wobble lead screws and bearing blocks video, Maker Mark says, you switch from threaded rod to Acme lead screw without any explanations of the difference between them. Is there a separate video for that? I've seen rather expensive printers using stainless threaded rod with rubber coupling. And I did answer a little bit below that, but I had another question on my Patreon page where somebody was asking about threaded rod as well. He also says, I suppose the T8 2mm lead screw are actually easier to manufacture, but effects on print quality, resolution, etc. would be an interesting topic on the Ender 3. Maybe it would be. I'll think about it. I'll have to see if I can source some decent quality threaded rod, which, if I can get back to the question, that is one of the problems with them. Now, there are a couple 3D printer part distributors that have threaded rod, and it's straight. I don't know if they sort through it and kind of like, you know, bin the straight ones, you know, and then just, you know, whatever the crooked ones. But regular threaded rod is not meant for linear motion. If anyone knows of a manufacturer that does linear motion threaded rod, let me know. It kind of fell out of vogue after the initial like rep prep period, after you got out of like the, you know, Prusa's, you know, I1, I2s, and then into, I think the early i3s had metric threaded rod on it too before they switched to the Acme screws. But the big thing with those was everyone was constantly struggling to get, you know, decent Z layers, like get rid of the banding and the wobble and things like that. Those screws are just not meant for linear motion. Now, if you get the good ones that are either cut and then rolled, or rolled and then touched up and then hardened, usually they're like inductive hardened, or they just double roll them and they work harden them. Those tend to be a lot more accurate than regular old threaded rod. When I still have a couple old printers in the closet that are threaded rod, or at least parts of the printers, and I actually went through a whole bunch of distributors looking for stuff that was straight. I was using just 6mm stuff because it had the 1mm thread pitch. It took a whole lot of doing to try to find, and then even when I did get it, the rod would kind of buckle underneath the weight, so a lot of people would hang them upside down to keep them in tension rather than, you know, compressing, because you're just accentuating that buckle. But they would bind up, and like those nuts are not meant for linear motion too. So I ended up using hardened 1mm pitch rod from McMaster Carr, and I got brass nut to put on it, and then put that in a captive inside like a little like a floating platform to kind of deal with the irregularities so that it wouldn't bind as much, and then used a flexible coupling on the bottom. And after all that stuff, it finally ended up printing beautifully, but it was a whole lot of work to get there. And when I first, like, I didn't buy a printer that had, like, you know, an Acme rod or a TR8x8 rod on it. When the prices came down and that was available from, like, overseas at, like, decent qualities, I just bought some of those. Actually, the first ones I bought were from openbuilds.com, the guys that did the open source linear rail stuff, or not linear rail, the shaped rail, the 2020 rail. And it was so easy to get good straight, you know, Z layer with no banding, like right off the bat with those, that I was like, I'm just never going to mess around with rod anymore. But I can experiment with that if that's something that people are interested in. Like, you know, YouTubing all the 3D printing stuff, you can probably go back in the archives and search for all of the probably thousands of threads about trying to get your, you know, Z layers decent with rod and all the little tricks and what have yous. Maybe I'll give it a go. Oh, another problem with it is that the thread pitch is very fine, so your axis moves very slowly. So if you're talking about, like, steps per millimeter of linear movement that you would, you know, input into your firmware with like a TR8 4-start or TR8x8 4-start, you know, metric rod, it might be like, you know, 400 or something like that. Whereas with linear rod, if you're talking like 32 steps, it's going to be 6,400 steps, you know, to the millimeter. So you really have to go pretty slowly because your steppers are going to run out of juice pretty quick. Okay, as you can hear, my voice is going bye-bye, so I'm going to end this here. Thanks for watching. If you dig this kind of stuff, check out my support links in the video description below. Again, sorry about the delay of the beginning of the Ender series and a live stream and all that kind of stuff. So until the next time, get out there and make something awesome.